So let's try a couple of simple examples. We're going to find the turning point on the graph of f of x equals x squared minus 4x plus 5 as our first example that we're going to do together. So if we have a little look at this, the solution is, well, first of all, we have to find where the turning point is. So that will be where the derivative is 0. Remember, we're looking for the level slopes, all right? In other words, where the tangent is horizontal. So to get f dashed x, the derivative equal to 0, we're going to start with x squared minus 4x plus 5. And then we're going to differentiate it, and we're going to get 2x minus 4. You really should be able to do that now. So we're going to set that equal to 0 to find the horizontal sections. And therefore 2x minus 4 will be 0, so 2x will be 4, so x will be 2. So our turning point exists at x equals 2. All right, so that's the location. To find the nature, you want to find the double derivative, f double dashed x. So let's just do that. So to find, so f dashed x is 2x minus 4. If you double differentiate that, you get 2. So notice that we're not really interested in what the value is. We're not really interested that it's 2, to be completely honest with you. What we're interested in is that it's bigger than 0. So because it's bigger than 0, the turning point must be a minimum. So we know that at x equals 2, we've got a minimum value. Now what about the value, the actual value? It would be a shame if you went through all that and never actually found out what the value actually was. The whole point is to try and find out what that value is. So all you need to do is, we know that the minimum value is x equals 2, so you just substitute that back in the original equation, which is f of x equals x squared minus 4x plus 5. And when you do that, when you put x as 2 back into that, it should give you 1. So the minimum value is the point P21. So x is 2, y is 1. I did a graph in Desmos, www.desmos.com, a quick plug there for Desmos, a great graphing tool. Just to confirm this, so this is what the graph of that function actually looks like, and as you can see, it does indeed have a minimum turning point at x equals 2 and y equals 1. This is the smallest this function ever gets. So that's how simple it is. So let's do another example. Again, we'll just use a simple quadratic. So example 2 here is find the turning point on the graph of y equals negative x squared plus 8x minus 11 and determine its nature using the second derivative method. So the first thing we do is locate the turning point. Again, the location is when dy by dx is 0. Now you need to state that. Do not just go straight into it without stating that. You will get marks for stating this. It's important. So dy by dx, then you need to find out where it's 0, but you need to find what dy by dx is first. And so starting from here, again, if you can't differentiate this, you are really in trouble. So I'm sure you all can by now. So dy by dx will be negative 2x plus 8. You set that equal to 0 to find the horizontal areas, the horizontal lines for the tangents. So 2x is 8, so x is 4. So again, we've got here that turning point exists at x equals 4 in this case. To find its nature, you must again go to the second derivative. So because the first derivative is that, when you differentiate it again to get the second derivative, you get negative 2. Again, you're not really interested in the actual value of that. We couldn't care less if it was negative 2 or not, or if it was negative 3 or negative 4. What's important is that it's negative. It's less than 0. So therefore, we've got a maximum turning point. And lastly, you then want to find the actual value, because why go through all that procedure not to actually find out, well, what is the value? What is the biggest this function gets? Well, again, you've got to find, you've got to substitute x equals 4 into this expression. So if you do that, you should come out with y equals 5. So the graph of y is negative x squared plus 8x minus 11. You've found out has got a maximum turning point at 4, 5. And again, at the end of all your problems, what I would like you to do is actually state state this. So tell me if it's a max or a min, state the location, state the value, state the actual point. And alternatively, as it says here, you could just say the graph of that has a maximum value of 5, x equals 4. But you need to tell me at some point that is the case. So I want you to go to worksheet 13, try examples 1a and 1b, and hopefully that's helped you get a handle into what we're going to be doing, and you should now be able to do all the quadratics. So next one up would be cubics or quartics or anything like that. So we're going to do that in the next few videos. So until that time, keep yourself safe, and hope that helped, and I'll see you soon.